Hello all, welcome to your channel DIY Community. Please subscribe to this channel and get access to exclusive content and resources. You will also become part of our DIY community where you can connect with like-minded individuals and receive support. Hi there. In today's session, we are going to see how can we design and develop our own chat application. Now the chat application or a messaging server, it means different to different people. For most of the people, a chat application or a messenger means something. If you send a message, then it will broadcast the same message to all your friends. For example, you can have a WhatsApp or Facebook messengers and so on. But the same logic can be applied to devices communicating with each other. For example, think about a group of drones communicating with each other. Similarly, a group of cars communicating with each other, and so a full-fledged chat service can be a very complicated application. It can involve user authentication, it can involve database persistence, and a lot of other various things. It all depends upon what features you want. Given the limited time we have today, we will be discussing on a very limited scope of this subject. But if you are planning to design your own chat server for a professional service, then obviously you will have to dig more and you will have to add more features and so on. But in this session, we will be discussing a very minimalistic chat server, and this topic will be useful only for your interviews and so etc. Now, before you start, there are some basic things which you need to know, and if you haven't done it before, then I will advise you to go to this application here on my YouTube channel, which is to design socket programming using asynchronous communication. So just go over this application, a small sample over there, which will help you to jumpstart. This application describes how can you make your own C++ application, a platform dependent one, which you can run on Windows, Linux, wherever you want. And it supports multiple clients. So that's a basic requirement before you want to build your own chat application. So our chat application, we will be using a observer design pattern. So what is a observer design pattern? This is a Wikipedia page I took as an example. So very high level, it is publisher subscriber kind of framework where you will have a subject which will maintain a list of observers, and as soon as some event happens, it will notify to all those observers. So in this particular case, let me magnify it. Yeah, here you go. So very basic flow diagram will be, as soon as a new chat client connects to the server, so the subject will register it. So what exactly registration means? It will add it to a list or vector or a queue or deck, any basic list structure here. And when a chat client sends a message, it will notify all the observers which are there in that particular list. So this is what it is, a very high level if you want to know observer. But as I mentioned, you will have to go a little bit of like more detail and read it yourself, what exactly and how can you design observer design pattern. Now let's see the code. So this is a very simple code, and it's a very like a trimmed down version of a chat server. So This is only for education purpose, as I mentioned, because it doesn't have any authentication service or it doesn't have any other feature here. So basically the purpose of this one is only to communicate and broadcast. So we are using namespaces and we are declaring our classes here. And these are the two interfaces which we are using. I kept the same names here, which is there on the Wikipedia page, which we have seen a few minutes ago. One of them is an observer, another one is a subject. So observer, all our chat client should derive from observer, and the subject, our subject should be a parent class for the controller in this application. So the controller means a class which is going to manage all the clients. It's like in a nutshell here. Now, how the observer will look like? Observer, the interface observer, it's very simple. So this one simply updates the client. That's all it is. And subject, again, it is very simple. The purpose of subject is to manage the clients. So it will register. So here I use the names like attach, detach, notify. So basically it's registering, unregistering, and it is notifying. So at this point of time, don't worry about this add message. I just kept it so that I can pass the events from observer to the subject. Now, these are our concrete implementations. So the first one is, let's start with this, a client session. So this is a client session which is deriving from observer class. So basically this client session is representing a client, and the function or the member which we have implemented from its interface is the update. And there are some other utility functions over here, like if you want to get the ID of a client, or you want to start, and then there's a constructor here. So in our previous applications, we have already seen what exactly is a socket and what is an IO context and so on. So I'm not going to repeat all those stuff here. Basically, we'll be focusing only on the members which are necessary for this chat application. For rest of the stuff, you have to go back to my previous video where we have seen asynchronous communication. So that particular video has more details. Now let's focus on what we are doing here. So read and write utility functions, they will read and write from the sockets. Again, go back to the previous video, it contains more details over here. Now it is maintaining a reference of all these objects here. That's it in the client session. Now, what is the client manager? Client manager, as the name is self-descriptive, it manages all the clients. So attach function will attach a client session to a client manager, and detach will unregister, notify will notify, and add message is simply add a message. Actually, you can use some kind of message queue here, which I'm not using here, but if you want, you can use it here. Now let's go to the actual code. So you can see the code is not that complicated. So we are declaring all the headers necessary for our applications, and this is the client manager. So it's very simple, as I'm repeating every time. So client manager, how does it register? There is a list I'm using in this application, or you can use whatever you want. You can use a map, you can use a vector, whatever you prefer. And then I'm pushing our clients to that list. That's it. That's what registration means for me here. And you have noticed I'm using a mutex here, lock, because it's a multi-client, or you can call it a it's internally it uses the threads and events, but I'm not specifically using threads. But still, you will be having a situation where multiple clients will be interacting with your system. So that's the reason why I'm using a lock here. So detach is exactly opposite of the previous one. It is removing a client from your list. That's it. So what does notify will do? Notify will loop through your list and it will update all the clients. It will simply send a message to all the clients. And there is a small check here. I do not want to send a message to the client which is sending the message to us. For example, if you have 3 clients connected with your system, A, B, and C. If client A is sending a message to client B and C, I only want to broadcast that message to B and C. I do not want to send the same message back to A. Otherwise, the same message will echo on client A's screen. I don't want that. That's the reason why there is a small check. I'm comparing IDs, which we'll see later in the code below. If the ID doesn't belong to the source, then it will broadcast. If it is source, it will simply skip. So add message is nothing. You can ignore it if you want. Directly call notify for this example, but I just left it a small callback kind of thing here. In case if you want to make it more efficient and you want to have a queue where you want to maintain your messages to make it more efficient, you can add it over here. But in my case, I'm simply calling the notify. So client session, as I mentioned, it is representing a client, a session of a client. So in the constructor, we are initializing the members. You see that I'm using a socket, I'm using a client manager, and I'm initializing is connected as false. Now, in the start method, which means as soon as a client session gets created and it starts, I'm going to attach my client, which is this particular one, using shade from this. I'm attaching it to the client manager. And as soon as it attached to a client manager, it starts reading. So here you can see we are using asynchronous communication, which means we are going to read the information, whatever the client is sending it to us from the socket. Now, as soon as we receive the message from a socket, we will add that message to client manager's queue. Actually, I'm not using queue, but you can use queue. I'm directly planning, I'm broadcasting it. So once that is done, it will again go into a loop and it will keep on reading. So in short, as soon as you get a message, you broadcast and you are back to reading. But for some reason, if there is an issue with the socket, then this client manager will remove the client from its list and it doesn't have to manage it. So this function update is going to update the client. So basically it means it is going to write to client's socket. Read is reading and update is writing. That's it. And who is calling update? It's notify here. Here you see the place where we are broadcasting our message. It is calling from the list. It will go one by one and it will pick up a client and it will write to the client. That's it. Then there are some utility functions. You can simply ignore it if you don't want to, but this is simply returning the ID of the client. And there is a destructor here. It is important, which means that as soon as some client close their session, this destructor will get triggered and it will detach itself from the client manager before it get destroyed. So this is the final component of our application. So this is the server. So server is just like a very basic server which initialize an acceptor with an IP address and the port number. It initializes socket, and it also initializes our client manager. So client manager, it's a list which maintains the clients. As soon as a server is ready, it starts accepting the messages. So in our previous videos, we have seen a life cycle of a socket, how it listens, how it binds, does the handshake, and it accepts. So as soon as the server is ready, it is ready to accept the clients. It will be waiting over there. As soon as a client message arrives, this gets triggered and it will accept it. So once a client message arrives and it accepts it and a handshake happen, a new client session get created using a new socket which will be dedicated for this particular client and server communication. And a reference to client manager is passed to the client, and the start member function is triggered. Basically, so this becomes like a loop. Every time a new client is arriving with a message, server will create a new session for that particular client, and it will trigger the start on a new socket which is dedicated for that particular client. This goes on, and this is the design which supports multiple clients to, communication with the server. So this is the starting point of our application. Main, it's very basic. It creates a IO context and creates an instance of a server. It is starting at port 8080, and that's all. So this is a very basic server which we have discussed today. So that's all for today, guys. Thank you for watching, and see you in the next video. Thanks for watching. Please subscribe to get more professional advice. In addition to our free online content, we also offer free online classes for students. These classes cover a range of topics, and they're designed to help you enhance your skill and knowledge. We encourage you to join us and take full advantage of this opportunity to learn and grow.